This video is to show my Doxygen DBC tool. The project consists of a bunch of command line tools that are used to manipulate DBC files. A DBC file is ingested and the comments are parsed in order to make a PDF file that documents the DBC. In the scenario described in this video, I'm calling the tools in the precompile and postcompile steps. This means when you hit build, everything runs behind the scenes. In the precompile steps, I take the DBC with the comments and strip the comments off and so that it can be used by external tools as well as the DBC to H generator. The DBC to H file generator takes in a DBC and creates a C and an H file that can be used by the embedded software. During postcompile, I'm calling a script that essentially takes the commented DBC and generates a Doxygen file that will then be ingested. We will now look at this script and see what all is done. You can see the first thing I do is called DBC Doxygen messages. What this does is parse the DBC file and generates documentation for all the messages, all the signals, and all the enumerations. This is done by putting all of this information into the pilot file. Next, we call DBC Doxygen alerts. This looks for a certain hot phrase and makes a special extra chapter in the documentation just for this signal. For this project, the hot phrase is alert ID. This means that anytime that a signal is called alert ID, it will generate a new chapter and have extra documentation. The next two calls in the script are called Doxygen DBC copy. What this does is it's used to copy a text file directly into the pilot file. In my case, I'm calling the entire DBC and the pilot file itself to be copied into the text. This means that the final documentation will have the raw DBC file copied in the appendix, and it will also have the pilot file itself in the appendix so you can see exactly what's happening. This may seem confusing, but it'll be obvious once you see the PDF that's generated. The final handful of tools are used to do stuff like insert the get hash into the PDF, change the PDF name, and then call the latex and Doxygen itself. I'm now going to go ahead and compile and show you what happens behind the scenes. In this case, it's being run on a shitty laptop, so it takes about 15 to 20 minutes to run, but on an actual good computer, it takes about 3 or 4 minutes. Now that the DBC file has been parsed and the PDF has been generated, we'll now go and look at what was created during the build. You can see that every single CAN message has been documented and everything as far as enumerations, NDNS, and all the data for each signal is present. You can also see that everything is hyperlinked in the PDF, which makes navigation easy. You can add as much information or as little information about each signal as you want. All you do is just add comments to the DBC. It even generates little tables for whenever there are really large enumerations. Since it uses off-the-shelf Doxygen, you can add pictures and comments and anything that you want into the document and it'll show up in the PDF. In the case of this project, I added a bunch of stuff on how you set up CAN bus. You can also see how I added the raw DBC into the appendix as well as the pilot file. I briefly touched on this in the beginning of the video. This PDF links a lot of external links, including this YouTube video of the system. To see the raw PDF that's been generated, it's attached to the YouTube video.